The diagram shows a circle, centre at O, radius r centimetres. Points A, B and C are such that A and B lie on the circle, and the tangents at A and B meet at the point C. Angle AOB is theta radians as shown. Given that the area of the major sector, so that's this bit round here, is 7 times the area of the minor sector, find the value of theta. So if that's theta, then this angle is 2 pi take away theta. The area of that major sector will be a half r squared times the angle, which is 2 pi take away theta. And that's going to be 7 times the area of the minor sector, which is a half r squared theta. And the half r squareds will completely cancel out there. So what we have is 2 pi minus theta equals 7 theta. Therefore, 2 pi is equal to 8 theta, and theta would therefore be 2 pi divided by 8, or pi by 4 radians. So we're now given that the perimeter of the minor sector is 20 centimetres, and we want to find r. So the perimeter, remember, is the distance around. So all the way around like that. So we'd have 2 radii, so that's 2r, and the arc. And the arc would be r theta, which we now know is pi by 4. And we know that that's equal to 20. So we have 2r plus pi r by 4 is equal to 20. Take out the common r, and then we've got 2 plus pi by 4. That's equal to 20. So r is equal to 20 over 2 plus pi by 4. Let's calculate that, and let's hope it's around 7.18. So we have got 20 over 2 add pi divided by 4, and it's 7.180 and so on, which is 7.18, correct to 2 decimal places, which is exactly what we wanted. So moving on with the question, the next thing says, using the values of theta and r from parts 1 and 2, find the perimeter of the shaded region ABC. Well, let's have a look at that shaded region. So that region is made up of the arc AB and then the straight line sections AC and AB, and we'll come back and look at those in a moment. So the perimeter is going to be AC plus AB plus r theta. So we'll write that down as r theta and put the actual values in a minute. It looks like a not equal to there. So that's a plus. So AC and AB, well, one thing we do know, tangent property, is that they are actually equal in length. So if we can work out one of them, we'll be fine. So let's just draw out here OAC. And the tangent property, we know that tangents and radii meet at right angles, so that's a right angle. And this is R here. And there's a symmetry here. So this angle would actually be pi by 8, half of the theta. So this would be the adjacent, and we'd like to know the length of the opposite. And so tan of pi by 8 would be equal to the opposite divided by the adjacent, which is r. So AC is going to be r tan pi by 8. So we can put that here. AC, which is equal to AB. That was right, wasn't it? No, it's CB. BC. And BC and AB are equal. And they're both equal to 7.18 times tan pi by 8. And we can work that out. I think my calculator is in degree mode at the moment, but just stick it in radian mode. And I've still got that on there, so I'll just use that. And we're going to do multiplied by the tangent of pi divided by 8. And that's going to give me 2.974. And so P is going to be 2 of those for AC and BC. Add 7.18 times theta, which was pi by 4. So we want that multiplied by 2, and then we want 7.18 multiplied by pi by 4, and that's, let's call it 11.6 centimeters, correct to 1 decimal place. And finally, we want the area of that shaded region. Well, we can work out the area of this triangle because we know the things we need for that. And then if we double it, we would get the whole of this, and then we could take away the sector, and that would give us the shaded region. So if we consider this to be the height, that's the 2.974, and R is the 7.18. So base, that would be the base, and that would be the height. So we are going to have twice a half times 7.18 times 2.974. That will give us the area of those two triangles, or if you like, that's the area of the kite that we have here. And then we'll need to take away from that the area of the sector, which is going to be a half times r squared times theta, which we found was pi by 4. So that should be the area that we want, and we can calculate that all in one go. So 2 times a half is just 1, so we've got 7.18 times 2.974. So that's that, and then we'll take away from that a half times 7.18 squared times pi by 4. And that gives me 1.11 centimeters squared, correct to 2 decimal places.